It strikes me upon reflecting on Professor O'Connor's talk that the titles of philosophical talks often lack magnitude and power. There's no sense of thumos. Unfortunately, the same is true of my title. One way of thinking about this talk is as a sequel to Professor O'Connor's talk and Professor Callahan's talk from yesterday. It's a hard act to follow Professor O'Connor. Doubtless I am a small man. So can only be elegant and well proportioned, but not beautiful. I think, well, there's an analogy between physical modeling and poetic modeling. The scope is somewhat more restricted. So maybe we're going to see, again, some of that lesser magnitude. But nonetheless, I think there is an important analogy to be drawn here. And one way of summarizing the point of this talk is by saying that it's an attempt to uncover how physics can be the object of wonder, how we can describe what we're doing in doing physics, such that we experience something of the magnitude and power and wonder when we're contemplating whatever it is that we contemplate in physics. And by the same token, how a certain kind of, well, what some people call philosophical attitude towards physics can denude and deracinate physics and strip it of its wonder. Is a really kind of iconoclastic attitude. I don't say this is philosophy, I say some people call it philosophy. But in more detail, here's the plan for today. So I'm going to talk about what I take to be a certain mistake that arises when we perform a certain kind of activity, an activity that contemporary philosophers often refer to as the interpretation of physical theories. And this mistake, I claim, is the result of a kind of literalism. Now, when I mean literal in the contemporary sense, namely, a literal conception is a conception that eliminates the use of metaphor or images. It's supposed to be completely exact. And so this is not the same use of literal as Augustine. It's not the use of literal that Professor Callahan had in mind, that older use of literal. Nothing much will hang on this usage. Replace it with a different term if you like. I could call it the exactness mistake or the precision mistake. But for the sake of convenience, I'll just call it the literalist mistake. It arises in a conception of the interpretation of physical theories that has really dominated the landscape of contemporary philosophy of science. And I'm going to proceed in the following way. First, I'll consider a challenge to this literalist conception from the phenomenon of idealization, from the fact that we can't help but idealize when we apply mathematics to represent physical aspects of the world, material aspects of the world. And then I'm going to consider a really revealing attempt by a philosopher named David Baker, who's at the University of Michigan, to salvage this kind of literalism. So I think it doesn't work, but it's nonetheless revealing because it misconstrues a genuine and subtle phenomenon that occurs in the interpretation of physics, not where this phenomenon is something that occurs in a practice not of philosophers, but of physicists. And the phenomenon is real, and it's important, and the phenomenon, I think, is at the heart of why we feel wonder when we contemplate things through the lens of physics, when we contemplate aspects of the material world through the lens of physics. Finally, I'll diagnose this mistake and offer an analogy with art in order to account for this genuine and subtle phenomenon. That's the path. Oh, by the way, there's going to be a couple of slides with lots of text, and I'll just read out, this isn't one of them, but I'll just read out those slides. So I'll ask you not to, burden yourselves by squinting at the screen. Okay, so this is, what I'm going to say now is we'll tell you about the foil for the talk. It's a conception of interpreting theories, interpreting physical theories. It comes from the philosopher of science, Bas van Fraassen. And it's been taken on by both people who agree with van Fraassen, also people who disagree vehemently with van Fraassen. They've taken on this conception as something to disagree with. All right. So here are two quotes from van Fraassen. There are two important relations that a theory, a physical theory, a scientific theory, may have to reality. The first is truth. This means that one of the models is an exact, emphasis, exact copy of reality. Each part or element of the model represents something real. And those real things are related in just the way that the model represents, where this just is, again, about exactness, precision, right? Here, van Fraassen is thinking of a theory as something like a collection of models. And the model is what's related to reality in this exact way. Now, given this kind of conception of the relation that the theory has to reality, this conception of what it is to say that the theory is true, exactly true, we come to the question of interpretation. That's the question: under what conditions is this theory true, exactly true? What does it say the world is like? Exactly like. And van Fraassen himself is an anti-realist. So he rejects this conception of realism. But everything he says about anti-realism is framed as a reaction to this conception of realism. Right? So there's a sense in which he too accepts this understanding of what it is for theory to represent reality. There are many basic questions that one might ask upon hearing this. This is a question for the audience, actually. Sounds good, but do you actually understand what this means? Do you understand it? I don't, actually. What's really meant here? And so this really harkens back to the kinds of questions that Professor Callahan was asking in his talk, except now focusing on the case of scientific theories, physical theories. So what is an exact copy of reality? What's this thing supposed to be anyway? What is an exact copy of reality? Often you hear people say something like, well, it means that reality is isomorphic to the model. Well, but wait, isomorphism is supposed to be a term from math, at least the way we understand it today. So used here, that's an analogy. Taken, it's a metaphor, sorry to say, it's a metaphor. But if we take it literally, then it doesn't make sense, because on the one hand, the model is a formal structure. On the other hand, reality is it's something concrete. So how can the two things be isomorphic? And furthermore, remember the problems raised by Book 10 of the Republic. So this is the business about, well, you can't be an exact copy of something unless you're that thing. Right, okay, right. So, and finally, what is this reality anyway? Something people often say is all of the real, or the robustly real, all of the really real. So there's two aspects of this to emphasize. One is the all, that it has to be a kind of universal synoptic conception of the representation, something exhaustive. And the other is the really, really real aspect. Um, this is hard to make sense of when it's internal to the conception of scientific theories that part of their interpretation is a specification of the domain where they do apply. And an understanding of the domain where they do apply is an empirical matter. Anyway, maybe I'll come back to that part later, but let me back off from this now. I want now to turn to a more detailed objection to this approach that's been given by a philosopher of physics named David Wallace. And the way David wants to run an objection from the perspective of idealization. So if you can't see, don't worry, I'll read it. So here's what Wallace says. He's trying to use the example of quantum field theory here, but it really doesn't matter what the theory is. It's going to apply to anything. It's the same structure the objection is going to apply. Okay, so here's the first thought. So if we are serious about understanding our best extant physics and using it to learn about the world, our world, the actual world, the right question isn't, what would the world be like in the hypothetical situation where there was no gravity and this other theory, quantum field theory, was exactly true? So it's conditional. It assumes that the task of interpretation is about understanding our best extant physics and using it to learn about our world. Nor is the right question, what would it be rational to believe about this theory, quantum field theory, if we lived in a world where there was no gravity, but this theory was empirically very successful? This question is fairly uninteresting for the simple reason that we do not live in such a world. And I think there's an extension of the thought here that David has, which is that not only do we not, is it because we don't live in such a world, but actually because we have no idea what it would be to live in such a world. It's not even a conception that, well, it's not even clear that that kind of conception is coherent, actually. David then goes on to say, the scientifically and philosophically interesting question has to be, what is it rational to believe about this theory, quantum field theory, given all the empirical data that we in fact have? Now, there's another philosopher named David Baker, whom I mentioned, who accepts Wallace's criticism, but wants to try to defend and salvage the literalist conception in a certain way. Okay? So here's David Baker acknowledging that the truth in what Wallace says. David Baker and Wallace, he says, I would generalize the point. For any theory we know to be exactly, again, highlight the word, exactly false, but a good approximation to the truth. The question of foremost interpretive interest, as Wallace says, is not what reality would be like if that theory were exactly true. Rather, the key question is what we ought to infer about the way reality actually is, based on the theory's success in the domains where it applies. So what Baker acknowledges is that Wallace is right about what the foremost interpretive question of interest is. The foremost interest is in what we ought to infer about the way reality actually is. However, Baker thinks that the literalist conception plays an important role in answering the question of telling us of what the world is actually like. So here's what he says. I hope to show that the right way to pursue this key question. So again, what's the key question, right? The key question is what we ought to infer about the way reality actually is based on this theory's success in the domains where it applies. So that's the key question. So he says the right way to pursue this key question is via first answering von Fraassen's question about a theory's exact truth conditions. Namely, it's to first answer the question of what would the world have to be like if the theory were exactly true? Determining what the world would be like if such a theory were exactly true is, on my view, a key step in figuring out what that theory's partial success can tell us about the real world. And key to this approach will be the notion of approximate truth. So the issue of approximate truth will be much less important for me. Let's proceed to view an example of how Baker attempts to do this. Okay, so to be clear, what's he attempting to do? He's attempting to show that the question of what would it be for this theory to be exactly true, this literalist conception, is going to be a key step in explaining how the theory actually applies to our world. And he accepts the challenge from Wallace that what we should ultimately be interested in is how the theory applies to our world. So the example of the key step is going to be a Newtonian example. And this is, it's going to be hard to see. I'll read it to you. So here's what he says about this example, quoting from Baker. Newtonian mechanics, for example, is approximately accurate only when describing a restricted class of physical possibilities. And so notice that here, in this statement, he's already taking on board the phenomenon of idealization, that in order to apply this formal theory to describe material aspects of reality, you're idealizing. He goes on to say, the most obvious limitation of this sort is given by the speed of light. When objects are moving relative to one another at speeds approaching that of light, relativity theory is needed to predict the behavior of these objects. Length contraction, time dilation will have noticeable effects. And, of course, the laws of Newtonian mechanics permit objects to move faster than the measured speed of light, which never happens in the real world. So, there is a large class of Newtonian states of the world described by Newtonian physics that cannot accurately represent real physical possibilities to any interesting degree of approximation. When interpreting the theory as an approximate representation of genuine physical possibilities, as opposed to a representation of possibilities for non-actual laws, we must begin by disregarding a bunch of Newtonian states that lie outside the theory's domain of application. In other words, we must disregard the Newtonian states in which things are moving faster than the speed of light. So notice what's going on here. The idea is supposed to be that first think of Newtonian mechanics as representing possibilities for non-actual laws, right? As representing things moving faster than the speed of light. That's what it is to say the theory is exactly true. Okay. That's viewing the theory as a representation of this special possible world. A possible world that is like our world in being a possible world, but unlike our world in not having the correct laws. Okay? This is the one in which the theory is exactly true. So start with that. And now, to apply it to the actual world, you do what you have to do, right? You talk about approximation, you discard the kinds of things you need to discard, and then you get a relation to our world, the actual world. Here's another example of his from Newtonian mechanics. Solutions of Newtonian mechanics represent objects, whether construed as particles or extended bodies, with precise spatial borders. Well, why precise spatial borders? Because in these solutions, the boundary of an object is represented as a surface, right? Surface is a mathematical object that has precise, so the surface is a precise border. It represents objects with precise spatial borders even at length scales where the theory is known to be inaccurate. For example, the theory has solutions in which two material objects pass each other by at a closest distance of 1/10 of a Planck length. So the Planck length is supposed to be the kind of scale at which quantum gravity effects are relevant. It treats these states as physically different from states in which the two objects come to contact, even though this kind of difference can only be drawn by appeal to physical distances that the theory can't actually describe. Because those differences can't be made out in the real world. That's the idea. Indeed, it is sometimes conjectured that our world's actual laws render distances shorter than the Planck length physically meaningless. So that's supposed to be a statement about the actual world now, right? So there is a good chance that this theory, Newtonian mechanics, when understood as an exactly true representation, is describing completely impossible states of affairs. Now for Baker, this is not a problem. In fact, he thinks that it's necessary to start from this conception of the theory being exactly true in order to then use that theory to approximate our world, what actually is the case. Okay, more generally, right, as the general flavor of this key step, when you think of Newtonian mechanics as exactly true, as representing this possible world in which what it describes is exactly true, all Newtonian states taken at face value, so this is Baker's locution, not mine. And remember what Professor Callahan said in his talk about face value. That's itself the use of a metaphor. All Newtonian states taken at face value represent reality at all length scales using the shortest ones. Good. So what's the key point that we're supposed to take away from the kind of argument that Baker wants to run? There is this thing called the face value interpretation of Newtonian mechanics. According to this interpretation, Newtonian states represent reality at all length scales with infinite precision or exactly. In this interpretation, objects have precise spatial borders, presumably isomorphic to some mathematical closed two-surface in three-dimensional space. In this interpretation, objects move faster than the speed of light. And only against this background can one go on to talk about approximate truth, and that's how one might model aspects of reality. Right. Where by reality I mean our actual world. And here's the question, does this make sense? I'm not asking whether the details of this are correct, actually. I'm actually asking whether the framework even makes sense. Does this even make sense as the kind of thing one might call interpretation? Actually. Okay, what are solutions to a Newtonian equation? Well, so think of these, okay, so what are states? States are solutions to a Newtonian equation, like what everyone is used to at some level from elementary physics. Mass times acceleration equals to some force function. That's just a differential equation. How does this represent something in physics? So that's a real, I think this is a much, much more basic question than getting to talk about possible worlds. I'm just asking, in the practice of physics, how does this represent anything? That's the basic question. And here's how anything like this represents. Fix some target empirical scenario subsystem that you're trying to model. And what it means to fix this means that you have to specify what the relevant degrees of freedom are, what you're trying to track over time. You have to specify a time and length scale of interest. You have to specify boundary conditions, which are part of saying what this subsystem is. The boundary conditions may be spatial, they may be temporal, they may be other things, but they're part of saying what this system is. Without the specification of such things, there is no physics. You're not talking about physics. This is how physics represents. Now, when you've specified these things, you're then in a position to use the solutions of the equation to model the dynamics of those degrees of freedom, namely saying how those variables change over time. Not any time, but the kinds of timescales that you think are relevant. And notice that this kind of procedure is shot through with idealization and metaphor. It is not exact, and it is scale dependent. It does not license the face value interpretation of how the theory represents reality. It does not license the idea that there is this special, innate, intrinsic content of Newtonian mechanics as a theory, in which what the theory represents is scale independent, precise at all scales. So I take this to be an argument against thinking that there is this special interpretation according to which we're saying the theory is exactly true in the way Baker wants. And yet, so what I'm going to say here is that it is a kind of concession. It's not a concession to what Baker says about representation. Representation is exactly true. But it is a concession to the idea that there is a kind of phenomenon here that takes place in physics that Baker and others and von Fraassen are misconstruing. And yet, is it not the case that we sometimes say things like, by we physicists, we say things like, in Newtonian mechanics there is no speed limit. And we say things that, in this theory, there are point particles. So surely we do say things like this. Surely when you look at a textbook, you find these forms of words. Right. Question, are these kinds of locutions just elliptical for general concepts that become representational when we apply them to empirical scenarios in the way that I just outlined? So I claim they certainly do play that role. They certainly are elliptical for general concepts that become representational when we apply them to empirical scenarios. But they are not just elliptical. And this is one of the main key points of the talk that I'm going to return to. Okay, they're not just elliptical. And that's something more to say here that's interesting. Nonetheless, these locutions should not be construed as a face value way of representing reality. That's exactly true. That face value way is a philosopher's fiction. Okay, here's another kind of example. I mentioned this example because I think Marta used it in a talk yesterday. Take the ideal gas law, that PV equals to some pressure times volume equals some constant times temperature. Is the content of the ideal gas law that PV equals to KT characterizes gases at all scales? Clearly not. It was understood really, really early on by people who use this law that it describes gases in the dilute regime. Quite generically. That there's a regime attached to the content of this representation. The philosopher, in quotes, is not improving either our knowledge of physics or revealing some deeper meaning of physics or of natural philosophy or metaphysics by intoning in somber tones a string of words like, aha, but interpreted at face value. This represents, the ideal gas law, represents a reality in which gases are exactly described in this way at all scales. Right. You're learning nothing when you're told this form of words. Here's the related but actually interesting question. What is the relationship between following two things? Those aspects of physical practice that some philosophers mistakenly construe as a theory's face value representation of reality, such as talking about precise spatial borders and how there's no speed limit inherent in the formalism of Newtonian mechanics. Inherent in the formalism of Newtonian mechanics. So again, I grant that we say things like this. Right. I think that the face value representation of reality is a misconstrual of why we say things like this. But I think there's something important in noticing that we say things like this. And I'd like to understand why that is. So what's the relationship between the phenomenon of our saying things like this, using this in our thought, and on the other hand, the second thing, applying the formalism in order to represent empirical scenarios, aspects of the material world. This key part of physics. To think about this relationship between the two aspects, I would like to draw on some resources from the philosophy of art. As you can see this, yeah, actually the color came out quite well. So, am I at 10? Am I at 10 minutes?
You're at 13.
Okay. All right, so unless you're a huge aficionado of St. Thomas More, you probably haven't seen this painting. So you've probably seen the famous one in the Frick in New York City, which is the one where he's represented as Lord Chancellor of England, and he's wearing the chain of the Lord Chancellor. Right. This is also a Holbein. It's a Holbein of More. It's at Windsor Castle, and it's done in very loosely. I think it's ink. And so what's interesting about this portrait? What does it convey to you about More? Simplicity, a kind of pensiveness, a kind of openness. If you've seen the one in the Frick, the really famous portrait of More, I should have put a picture up here, where he's wearing the chain of the Lord Chancellor. You see a man with magnitude, right? You see a man of steel. You see the grit, the determination. And here you see this simplicity, openness, pensiveness, tenderness, actually. And that's no accident, of course, because this was a study that Holbein did before he painted More's family portrait, the one where More's with all his sons and daughters and his wife. That portrait's been lost to us. There's a reconstruction. But this is the study for that we still have. And why is it that we perceive it as tender, pensive, open, meditative? Why is that? In part, well, we won't have time to get fully into this, but in large part, it's by attending to the stroke, the character of the stroke. The stroke is loose, right? It's expressive. It has that quality that you get with the best chalk sketches, actually. Right? It has this casualness that's carried already in part by the medium. This portrait is, of course, a portrait of an actual man, St. Thomas More. But one could, of course, also direct one's attention to the man one encounters in the world of the portrait, as someone would who did not know Thomas More at all, don't know of Thomas More. We just encounter him, you say, oh, well, I see the man in the portrait. Okay. I see a man in the world of the portrait. I'm going to use this language of the world of the portrait. But notice I do not mean a possible world in the sense in which metaphysicians talk about possible worlds. This is not a world that is like our world, except that it's not the actual world. The point of talking about world here is to specify, to draw your attention to the imaginative setting of the painting. And in this in the world of the portrait, one follows the formulation and procedures of the medium. So by the medium, I mean the two-dimensional canvas and the marks on the canvas and the quality of those marks. My use of medium is going to be a catch-all for all those things. So impasto is a part of the medium. Pointillism is a part of the medium. All these things are part of the medium. Here one follows the formulation and procedures of the medium in order to pursue an understanding of the subject, of the man one sees in the world of the portrait. One could speak of the loose stroke, indeed the loose delineation of More's borders and his parts. Now that's a really flat-footed way to speak, but you'll see why I'm going here in a moment. So clearly there's the loose delineation of More's borders and parts. In doing so, should one be construed as giving a face value interpretation according to which More has fuzzy borders in some possible world, when we take the painting to be exactly true? No. But there's still a point to this kind of talk. Right? There's still a point to talking about the loose delineation of More's borders. The point is the mutually sustaining relationship between attending to the properties of the medium, the loose stroke, seen already in part under the aspect of the subject, understood already in part under the aspect of seeing this man, and the representation of the actual man, More. Similarly, there's a mutually sustaining relationship between attending to the mathematical medium of Newtonian mechanics, where we say things like, it formally allows states with arbitrarily high velocity. See, we're talking about the medium, but it's already in part seen under the aspect of the subject, namely the modeling of material things in our world. It's the mutually sustaining relationship between that kind of attention and the use of that medium to represent an empirical scenario. Notice that this kind of understanding of the discourse of saying, oh, this theory allows states of arbitrarily high velocities. It presumes idealization in understanding that kind of discourse. That's presupposed. It's a precondition of being able to meaningfully use this discourse. It's the exact opposite of trying to construe this discourse as discourse about an exact copy of reality. Here's another kind of analogy. So I'm not saying it's exactly the same, but I think it's helpful. Consider entering the world of Tolkien's Lord of the Rings with its elves, hobbits, and orcs. By entering the world here, look, I'm not talking about cosplay. Okay, let's just be clear about that. I mean entering the literary world. You are not being asked to contemplate a possible world like ours, except not actual. It's a literary world. It would be a deep misunderstanding if my children, who are mad about Lord of the Rings, if they after reading it, they sat down and said, well, what's really essential to grasping what's going on in Lord of the Rings is figuring out what the right account of the laws of nature are, such that the elves could walk on snow, and right, you don't need to sleep. Notice that it's a literary world, and the devices of this literary world, the ways in which what's said about the elves and the orcs amplify and intensify our understanding of our world, they stand in mutually sustaining relationship with the ways in which the Lord of the Rings, quite elliptically, furthers our understanding of reality, furthers our understanding of something about human experience. Or consider entering the world of Othello. Again, what you're being asked to enter here is a dramatic world, not a possible world. And you do not believe that Desdemona is being murdered in the usual sense. Right? You don't actually think someone's being killed in front of you. There's some modern plays that try to make you think this, and it's horrifying, actually. It is a precondition of entering this kind of world that you acknowledge its idealizations, that you actually understand as you're perceiving the murder of Desdemona, that this is it's being enacted. So here's the moral. Talk of a scientific model being an exact copy of reality, or of the possible world in which theory X is exactly true, is a grave misunderstanding of certain aspects of the practice of physics. Namely, those aspects in which we enter the world of the physical representation and imaginatively use some part of the medium of formalism to further our sense of how the model in fact represents empirical scenarios. This kind of imaginative engagement assumes that the model is an idealization. And here we may well speak of secondary belief. We can talk about that during Q&A if you like. Question, is this, or maybe I'll suggest, that this kind of misunderstanding is akin to Professor O'Connor's diagnosis of juxtaposing or reducing a tragedy to philosophy. That it's a kind of it's akin to a kind of moralizing of tragedy. The kind of moralizing of tragedy that makes tragedy lose its power as tragedy. And similarly, this kind of construal of talk of perfectly licit talk, and essential talk, actually, of the theory permitting arbitrarily high velocities, the misconstrual is a kind of faux philosophizing of the theory, akin to moralizing, that strips physics of all the wonder, all the thumos, all the power that makes it interesting to begin with. Thank you very much for your attention.